Esta es la presentación de reptiles, de herpetología. Yo soy Alberto, el jefe de herpetología. No me ha dado tiempo para prepararla en español, así que voy a hacerla en inglés. Lo siento. Okay, so entering the world of herpetology, you might wonder, why are we studying these animals? Well, I mean, some of us passed their childhood playing with dinosaurs, not raising my hand, but that was me, and some other of us just find these animals interesting. Some of us don't understand why we're doing this, but that's why I put this first picture, because I want to leave this to the world of a much more wiser man than I am. Let's start now with what's herpetology about. Herpetology is about herpeton, according to the Greeks, meaning about those creeping animals, animals crawling on the ground that, even though this sounds really, really bad, are actually quite nice guys. So what do we consider a creeping animal? Creeping animals are, in general, poikilothermic, ectothermic animals, which means that are animals poikilothermic, that cannot control their body temperature, and ectothermic, that their body temperature is influenced by the outside environment. In particular, we studied tetrapods, which means animals with 4 legs. So at this point you might ask, how many legs does the snake have? None. That's the right answer, but still, sometime in the past, snakes used to have legs. They just evolved differently from then on. And what do these animals need to thrive and survive? They need 3 characteristics in particular, both in captivity and in the wild. They need heat, humidity, and there I put sunlight, but in general we can say light. Light is composed by 2 types of radiations, what we see and what we don't see. In particular, what we see is the UVA, meaning light, colors and stuff, and what we don't see is the UVB, which is the solar radiation itself. Reptiles in particular need UVB light because the rays containing that light activate vitamin D in their body, and this vitamin helps the uptake of calcium from the digestive tract in order for it to go to the bones and have bone formation and constant growth, destruction and reconstruction of the bones through our life. Reptiles, and most of the reptiles, amphibians, need humidity because, well, reptiles because they needed to shed their skin. As you might know, while a reptile gets older in time, it sheds its skin, like changes its old skin, it molds and creates a new one under it. And this is a process that is really, really fast, relatively fast, let's say, like if you think about a tortoise, but in comparison it's really fast when the animals are really young, and then it gets slower in time, but it never stops. There is no reptile that stops shedding at some point, just it gets less and less often in time. And then, well, of course, for the reasons said before, they need heat. I believe there is no question about this. Why, again, do we study reptiles and amphibians? Because of the 2 people that spoke here this morning, considering me, Javi, and okay, Vidar is a person aside, but Javi believes that his group of birds is really, really important, that they should deserve a group by themselves. But actually, if you look at the phylogeny, birds are reptiles. When we come to divide the order Reptilia in 5, we find that birds are part of them, aves. More than this, we all know dinosaurs, don't we? So if you remember the dinosaur in the previous picture, that was a Dimetrodon, which was not a true dinosaur by itself, so Jurassic Park is actually frauding you, be careful. It's actually a reptile, but not a dinosaur. And from that reptile in particular, all the mammals evolved, which is pretty rad if you ask me. I think it's so cool that we can study today animals that are, in some cases, even older than the most common dinosaurs. And those animals in particular are crocodiles of the order Crocodilia and turtles of the order Testudines. There are no species of turtle or crocodiles today that is still alive, that is as old as dinosaurs, but the pristine turtles and crocodiles were there before Tyrannosaurus rex, for example. They're older than them, and we still have them today. And still you will see they're a quite advanced animal for being more than 50 million years old. Okay, reptiles, we start with saurians. What's a saurian? Lizard. Long story short, saurians are lizards. There are animals belonging to the suborder Lacertilia, which in Latin means lizard. There we go. And as all the reptiles are in constant need of heat, humidity, and light, and these characteristics vary a lot depending on the species. Why am I saying this? I'm saying this because when you buy a reptile, they probably tell you that a diurnal reptile needs a lamp and needs UV light, which is true, whilst a nocturnal doesn't, because nocturnal animals, they like stay hidden in rocks and burrows for the whole day, and then they come out at night, which is not true. Because if you see this picture that I took by myself, I know it's really not clear, but you will download the presentation later on, that I took by myself behind the hospital. That's a gecko typical of Spain and the Mediterranean basin. It's called, scientific name, I love scientific names. It's Tarentola mauritanica, common house gecko if you want to. And that's a nocturnal animal. So what was it doing outside at 12 a.m. behind a hospital with 27 degrees? It's thermoregulating. It's behaving like any other reptile does. This means that there are no fixed rules. There are general rules, but reptiles is such a wide group of animals that many of them break these rules, and they evolved to break these rules to survive until the days of today. So when you hear me saying during the presentation, oh, it's like this, it's probably generally like this, but there are some exceptions. There are just so many of them that it's really, really hard to get through with all of them. So let's say you want to buy a reptile. First thing you get is a terrarium, meaning a place where to keep your animal safe, where to reproduce its natural environment as much as you can throughout its life. Then your first question is, how big is this reptile going to become? How big a terrarium should I get? Well, all the measures that you will find in this presentation are taken from the official document released by the Italian Association of Exotic Animals Veterinarians. And they suggest that for an animal living on the ground, like a bearded dragon, as we're going to see later on, for example, the minimum length for the animal to thrive when adult, it's 6 times its rostrocloacal length. Do you know what a cloaca is? It's going to be really interactive, so if you know, like say yes. Yes. Great. Now, much more merrier if you can. Calculating the length of the animal from the point of the nose to the cloaca, which is the point of conjunction of the urinary, the digestive, and the reproductive system of reptiles. You calculate that 6 times that length, and you find the total length of the terrarium that you should get. Same thing for the width and for the height. Of course, these are rules for terrestrial, let's say, saurians. And if you, for example, get a gecko or a chameleon more than anything, they don't live on the ground because they're animals which are really easy to prey and they're really, really tiny. So they'd rather live on walls or on trees. So in that case, you have to adapt those measures to what are their needs. In particular, chameleons, they need a really high space. If we talk about the leopard chameleon, which like big animals get to a dimension of like 40 centimeters, let's say, we talk of the terrarium of like 1.5 meters in height, even more. And well, of course, I believe that you got now clear why we need humidity, but what you have to know also is that not all the reptiles, due to these adaptations, drink water from the same way. Okay, all the reptiles drink. Some people might tell you that they soak in baths of water because they can absorb water from the cloaca. It's totally wrong. There is no water absorption from the cloaca whatsoever. And I'm sorry because I couldn't find a video, but I will post it on the journal group. There was an experiment done on a dead bearded dragon. The dragon had to be euthanized because it was really sick. So what they did was putting the body inside of a bath of water and a pigment, a blue pigment, and in the same time, they still stimulated the breathing receptors of the animal. So the animal was technically medically dead, but was still breathing, in order to see what body function was involved into his drinking system. And not surprisingly at all, the animal didn't take any pigment up from the cloaca. So when the necropsy was done, there was no trace of blue pigment in the body. So be really careful with this. It's also true, though, that not all of the reptiles in a small environment such as a terrarium need a water source. For example, desertic animals which live at an average environmental humidity of like 5-10% at best. If you put a water ball instead of a terrarium like that, the humidity is going to rise to super high levels, 60, 70%, which, as you might understand, it's not physiological for them at all. And this can lead to breathing problems, in particular pneumonia. Pneumonia, it's really common in people that keep water balls or misting systems instead of terrarium of bearded dragons, which are desertic animals, or other leases like that. Also, other animals such as chameleons, which ironically enough are really static animals, but they don't drink static water. You need an active dripping system because the chameleon will like see and recognize the water as like a water source, just if the water drips really slowly throughout the day. There have been many people like their chameleon died of dehydration, but they have water inside. Yes, but it was still. The chameleon just saw the reflection on itself in the water, which was a really, really, really high stress source, by the way, and didn't move and just stayed on a branch like this from day one until it died. And reptiles can do this as well. They're really funny. And then when you build a terrarium, what I like, but it's not the general rule, it's reproducing as much as we can in the natural environment. This is actually a terrarium built for snakes, but this gives a good example. As you can see, there is a visible light. The terrarium is like lighten up, and at the same time, the animal has natural burrowing and hiding spots throughout the place. This means that they can develop a natural behavior. For the people of first year, this year you're going to have ethology, you're going to go to the biopark, you're going to see animals not always behaving naturally. And you can see patterns in this. The thing is, in reptiles, it's not clearly studied. But for example, if you know a little bit of reptiles, you probably know in Spanish is dragoncino, or water Vietnamese, Chinese dragon in English. Scientific name Physignathus cochinchinus. When you go and buy them, you see they have very massive rostral injuries, like injuries on the top of the nose. That's because they're not stimulated, they don't feel good in a terrarium. So what they do is attacking their own reflection on the glass. And they do that trying to get away, but that's just because you're not providing them with what they need. More than this, talking about the substrate, you have to put something on the bottom of your terrarium, of course. And many people like to keep it aseptic, which is not bad. They just put paper towels in it, and when the animal defecates or whatever, they just remove it, and that's the end of it. But it's not bad by itself. It's just not 100% natural, and this is just a matter of opinions, actually. I like having a substrate which is made of like natural living soil, where I also put animals, like little bugs or critters that can eat up feces and results of the molds of the animal. So you have like an actual ecosystem sustaining itself in your terrarium. And I think this is like really fascinating and should be the goal of many breeders and keepers nowadays. Talking about diet, reptiles evolved in 3 main categories: carnivores, herbivores, and omnivores. Again, as you might know, there are some species which are presented to you as like strictly herbivores. Throughout their lives, you have to give them just vegetables. Absolutely, like iguanas, tortoises, or other lizards in particular. But there you can see a tortoise eating a train. So what is going on? They clearly like something else. Yes, the point is that many reptiles in the wild are opportunistic predators. It means that they can eat whatever they find. For example, that's a Mexican iguana, and it's eating an owl, which is a small lizard, Anolis equestris. But that iguana should be herbivore. So what do we do in captivity? What we do in captivity is trying to replicate as much as we can their diets in the natural environment, knowing that we don't know everything about it. In particular, there are tortoise keepers here, I know, that don't provide proteins to their tortoise, and this is totally fine. Like statistically, many tortoises have lived their whole life without any protein intake. But this is the thing, we don't know much about these animals. So what would happen if all the people all of a sudden gave them those proteins that they look for in the wild? Small tortoises eat bugs of any type, eat worms. And when they find dead or dying mammals, they eat them as well. It's not rare to find this type of videos of YouTube, even not of carnivore tortoises, but also herbivore ones. So what we do is we came up with this sort of charts. What we know so far is that, I know it's not really clear seen from back there, but I'm going to give you the presentation if you're interested in it. What we know so far is that some of the prey items that we give to them right now are better than others. We have analyzed them, and we know that a reptile to thrive needs a high content of calcium, for what I said before. So that's a list of vegetables which have a really high content of calcium. In particular, what you want is not only the high content of calcium, it's the proportion, the balance between calcium and phosphorus. Because as you might know, when you eat calcium and you eat phosphorus, phosphorus tends to bind to calcium, and that calcium is no longer viable for bone fixation. Therefore, what you have to aim for, it's a ratio calcium-phosphorus of 2:1. For example, if we take turnip greens, I really don't know how to say it in Spanish, I'm sorry. We can see that their content of calcium is 694 milligrams, and the content of phosphorus, it's 95, almost 100 milligrams. This means that they have a calcium-phosphorus balance of 6:1. That's probably the best thing you want to give to your herbivore animals. On the other side, things get much more complicated when we go into carnivore lizards. That's because none, and I'm saying no bug whatsoever by itself can proportionate this ratio of 2:1 calcium phosphorus. So what do we do? What do we do is either we dust the prey items with like powdered calcium and powdered calcium with added vitamin D3, which is really nice, but can lead to problems because it's really easy, especially with the vitamin. Vitamins can be really useful, but they can get toxic super fast for our bodies. So it's really easy to overestimate the quantity of vitamins and get to damage our own animals, which is not what we want, of course. So what we do usually, it's gut loading these animals. To gut load means bind the prey items possibly alive or bind them from a place where we know that they feed them correctly and feed them with all of those vegetables there that proportionate a lot of calcium, a lot of proteins, a lot of vitamins, and then, just then we give them to our lizards. That's the best source we have because eating the whole prey, they also intake what's inside of the digestive system. And now we go about the market part. Market meaning the most common species. Most common doesn't always mean easy, be careful. But for example, that's a bearded dragon, Dragon barbuto, scientific name Pogona viticeps. Then leopard gecko, the one that many of you have, if you have reptiles, I believe. Eublephalis macularius. There is a mistake here. This is the iguana, of course. And that's the tiliqua. Tiliqua, common name is blue-tongued skink. I believe you can know why. And then we have two other really common gecko species, which are gargoyle, both referred to as gargoyle geckos. And that's why I don't like common names, because they're actually two different animals, as you can see. One is Rhacodactylus auriculatus, which is this one, which means that, auriculatus means that his particular characteristic are his big ears, and this is the ear they're talking about, the crest beyond the ears themselves. And this is the Corellophus ciliatus, which means ciliated. It means it has cilia. It means it has really big eyelashes. It's really cute. And they talk about these eyelashes in particular, which are not true eyelashes. They're just ornamental part of keratinized skin. Prices. These animals on the market vary a lot depending on the species. The age, usually a baby is cheaper because raising one of these animals, it means that you have to invest a lot of money. So selling an animal that is already like 5 years old, complete adult, it means you have paid food, terrarium, electricity, everything the animal needed for 5 years. And sex. Generally speaking, not always, generally speaking, females are more expensive than males. Can you guess why? Yes, they can make babies. So if you buy a female, you'll have more of them to sell in the future if you want to do that. Of course, it varies a lot depending on the species. We vary, like a baby bearded dragon in its normal coloration, which is not that one, can cost what? 10 euros? 20 euros tops? If you buy for 30, they're probably scamming you. But then what the people interested in colorations did was selecting them according to their colors and sometimes even sizes. And they came up with morphs. In English, they're named morphs. In Spanish, fases. There are just different types of coloration and pattern distribution, and in some rare occasions, again, sizes of these animals just for them to be pretty. So this is an ancestral iguana. This is how you would see an iguana in the wild. That's how you would see blue-tongued skink in the wild. These are totally not how you would see geckos and bearded dragon in the wild. They're just really, really nice, and their price can skyrocket. I believe Omar commented me 2 days ago that there is now more of a genetic selection of a color of ball python, Python real, Python regius, that is now sold for 50,000 euros. And prices don't keep stable because they're like, especially those animals are really prolific. They make a lot of eggs every year. So what you now buy for 50,000, in 5 years you can buy for 1,000. Like the first albino python that came up on the market was 130,000. They still were not the euros, equivalent of euros, at least in Italy. And now an albino ball python, how much is it? Albino. 150 euros. I mean, it reduced its price by how many hundreds %? This is how the market goes, sadly, most of the times. But also when you go and buy animals, what you will see, especially if you go in a fair or on a website that deals with, directly with the breeders, are these types of nomenclature. WC, which means wild captures. It means the animal was caught physically in the wild, put in a bag, shipped overseas, and now it's sold to you. Take the conclusions of this. I don't want to get into ethics. CB, which is captive bred, which means that the animal was actually was hatched in captivity and was kept in captivity ever since. Probably it's captive bred since many generations. Like now, Australia closed the exportations of all of their animals, if not with special documents. So bearded dragons, Pogona viticeps, which is from Australia, you will never find wild caught anymore. And those are animals that have been kept since the 80s, the 70s. So can you imagine, like, considering that every year a female can lay a clutch of 25 eggs, can you imagine for how many generations have we had these animals in captivity now? Not nearly as close as domestic species. They're in fact not considered domestic animals, but you know, with time, there's a chance we're going to get there if we don't get extinct before that. And then you find these other three types of nomenclature, which is numbers. And those indicates the sex of the animal that you're buying when it's known. So 1.0, when there is a number before a 0, it means you're buying a male. 1.0, you're buying one male. Then there is 0.2. 0 before a number means it's female. Those are example numbers. So 0 before number means female. 0.2 in particular means you're buying 2 females. Great. So 0.0.3, what does that mean? You don't know the sex. Great. And this is what happens with most of the species nowadays, especially with snakes. Reptiles, usually it's easier, but like varanades, varanos, they're really, really hard to sex differentiate. Like of all of these animals, the bearded dragon and the geckos you can already buy when they're like this big and you already know the sex of them because they have some somatic characteristics we're going to see later on. Iguanas, they get evident with age. And the blue-tongued skinks, or skinks in general, they don't have any sexual dimorphism whatsoever. So what you do, if you want to be sure, either you buy a pair and you pray the gods are going to breed with someone, either you're going to do a DNA test to tell the sex of your animals. Quite expensive, but it's worth it. And there we go, into sexing. So we have primal and secondary characteristics, of course. Primary characteristics are the one typical of males and the one typical of females, that just males or females can have. For example, having a penis, or in the case of many lizards, 2 of them, and also many snakes, 2 of them, means that they're a male. Not having them, of course, means they're a female. So we're going to see later on during the handling part of this talk how to tell the sex of the most common species. But in general, if we look at a bearded dragon, which is the lizard that we saw before, we're going to see also later on, when you lift the tail, you can check if they have a groove or if the tail is like plain. If they have a groove, it means that this space is actually empty, and these 2 spaces on the sides are taken by the 2 hemipenises. This means we have a male. Also, males tend to have these things, which are called femoral pores, are pores that secrete some type of wax that the animal uses to keep its cloaca clean and also uses to mark the harem territory most of the times. But rather than this, we really don't know what they are there for, except getting plugged in captivity and having us to have surgery on them to remove them and earning a lot of money because of this. Really nice lizards, thank you. And there we go to secondary characteristics, which can be size, color, in some animals, the presence of like a dewlap. Like if you see this iguana, you would probably think it's a male. But then again, exceptions. In the wild, it's not rare to see iguanas that are like in packs, let's say, herds, groups, whatever you want, schools of iguana, like if they were fish, that are all females, and there is one which has developed this secondary characteristic. She is the alpha female. She is the head of the situation there, but she's still genetically a female. So this happens also in the wild, because even though we don't know much about their brain, we know that sometimes the most evolved of them, which usually means, most evolved means the bigger ones, they, what they do is they try to put themselves on top of us, like hierarchy-wise. So it's not rare for people in captivity having one iguana and saying, oh, this is definitely a male. But have you tested it? No, but look at this, it's definitely a male. And someday it lays eggs. Non-fertilized eggs, but it lays eggs. That's not what a male does usually. Meaning that we can't never really rely on sexing techniques. In saurians, it's fine, but you're going to see later on in other animals leads to disasters, such as people keeping two snakes together in the same cage hoping that they will mate, and actually one of them eating the other. So sad. Then we go to common pathologies. I'm going to skip through it because I know that the guys in my group are going to go in depth with common pathologies of animals, but just for your knowledge, reptiles, 95% of cases, if your animal is sick, it means you're not properly taking care of it. And poor husbandry is reflected in the bone structure. That's an animal which was never fed the right amount of calcium-phosphorus balance, or was never exposed to UVB lights. Even though it's true that we still don't know how much UVB lights affects the bone formation of nocturnal species. And that's what it translates into. It translates into metabolic bone disease, which is a condition by which the bones cannot be formed properly because of the lack of the calcium that we mentioned before, and the animal gets crooked. And this is an animal that got saved at the very last moment. This type of disease never makes the animal go back to its original state. That's an animal's going to stay like that until the end of its days. Not optimal. Not for the animal's health, not for like aesthetical purposes, of course. And this disease can be lethal because when the body is out of calcium, as we all know now, because I think you had your physiology 1 exam already, right? Which part of the body really needs calcium to make all the body work? And calcium is needed for the body for one thing: muscular contraction. Think about a heart with no calcium whatsoever. So that's what happens. The thyroid hormones take away calcium from the bones to feed the heart until the animal becomes rubbery, literally rubbery. You can take the skull of an animal like this, of course not that one because now it's okay, but of an animal dead because of this, and you can just bend it in your fingers and it's going to look like a toy. It's awful. It's really, really awful. Then, of course, other pathologies caused by bad management are burns. To keep these animals alive, we need to heat them. If they get too close to the heat source, they're going to burn themselves. Easy as that. It's up to us to prevent this from happening. And then, again, as said before, hypovitaminosis in particular, and infectious pathologies in general. Many of them are viral, and we still have to really get to understand what causes what. But many of them are, for example, fungical, caused by mushrooms, like this one. And in particular, we talk about Aspergillus, Fusarius, Candida, really common mushrooms that you can find any place, really. You can just be not aerating enough the terrarium, and the mushroom is going to grow, and the hyphae are going to deposit on the body of the animal, and that's what you get. Is just that. So again, I cannot put my accent enough on how important is it to properly take care of this animal, to get informed before buying one. And then we go to snakes, ophidians. They belong to the suborder Serpentes or Ophidia, as you want to say, doesn't change anything. Brief recollect about their anatomy. They have no eyelids whatsoever. It means they cannot close their eyes. It means that they never sleep. They just go into a resting mode, let's say, but as soon as you get close to them, they're just going to wake up. They cannot physically sleep because they have no mechanism to block light waves coming from their eye to their brain. So their brain is constantly like maybe on low energy function, but it's constantly working for how much the brain of a snake can work anyway. And in general, we have paired organs such as, for example, kidneys, lungs, testicle, ovaries, which are not symmetrical all along the body. So it's not rare to find a kidney in the second third of the body length of the snake, and the second one in the last third of the body length of the snake, for example. Plus, because they have to eat whole prey items, which usually are bigger than their body width, what they do is they can displace really easily these organs all along their body, meaning that also the heart can be displaced all along the body according to the movement of the prey inside of the body itself. This is why when we take blood samples from a snake, it's really freaking hard, because what we do, it's in the majority of cases, is taking it from the heart itself, and we have to localize it. We know, we're going to do it later on anyway, not the blood sample, but localizing the heart. We know that usually it's in the first third of the body, but it can move according to when the snake has eaten, so it gets much more complicated. And most of snakes have 2 lungs, but just one of them is working. The other one is vestigial. It's still there. We don't know why, we don't know how. At some point during their evolutionary history, they just stopped using one lung. They're living completely fine without it. And some others, the most evolved ones, they just have one lung and nothing more. It's just like that. And all the snakes, they have a Jacobson organ. As you might see, as you will see definitely later on with the snakes, they tend to flick their tongue a lot. They do that because with the tongue they can capture particles of smells. As you know, smells are organic compounds circulating in the air. They catch these organic compounds, they take them back in their mouth, and in the part of the hard palate they have an access to an organ which is called Jacobson's organ. And that's their main olfactory organ of the body. It's much more advanced than our nose in this sense. And it's much more advanced than the nose of many other animals in the wild. They still are studying which animal has the most powerful olfact instinct. If it's wolves or snakes, they're incredible animals. Some snakes in particular, especially pythons and some boids, like boas in general, they have some pits on the mouth. You'll probably see them later on. These pits are thermoreceptive, which means that even though they cannot see really well, what they do is seeing with a sort of thermic camera positioned on their face. They can trace down prey according to their body temperature. It's insane. And this leads us to the fact that many snakes have many different anatomical adaptations depending on where they live. Like we know that all the snakes can resist without breathing for quite a long time, meaning underwater. But if you think about the sea snake, they can stay underwater for hours and still survive. If you think about, there is a species of snake, which I don't know if you know, but I'm not going to bother you with scientific names, don't worry, that lives up in the trees. And when the predators arrive, its only way to survive is throwing itself down off those same trees. So what do? Do you like jump to your own death, not to be eaten by an eagle? No. They simply flatter their bodies. It becomes like this flat, and they can just glide through the air like flying for 1 kilometer, I think, if they don't land on another tree before that. Insane animals. Then we go to hunting techniques. There are 3 main ones. Some snakes just eat their prey alive. They just wrap themselves around the prey, or even not, and when the prey is starved enough but still alive, they just start eating it. Some other snakes, they constrict the animals. And many people believe that constriction means they suffocate the animals, but this is ridiculous. If you think about a huge reticulated python, Malayopeto reticulatus, which is the longest reptile on Earth, it hunts animals as big as deers. Of course, not adult ones, but young subadult deers, which, I mean, it's like what, this tall? They're animals that weigh a lot of kilos. They're really strong animals with a really strong neck muscles. So it would take a lot of time to strangulate, to suffocate one of those animals. What they actually do is the pressure of the muscles on their body cage creates a cardiac arrest by stimulating mechanically the sodium-potassium pump. So they obligate the sodium-potassium pump to open and the heart cannot beat anymore. So the animal actually die of cardiac arrest, and that's when they eat their prey. And then we talk about snakes that use venom. And this is a mess. Get ready. Okay, snakes can be either venomous, either poisonous. Does anybody know what's the difference? Doo-doo-doo. Nobody. Okay. So, back to the start. Snakes have 4 different types of dentition. Their teeth can be in 4 different shapes. Species, like one species have just one shape of teeth. Not toxic snakes, they are cataloged as aglypha, which means without the glyph. Glyph is what we refer to when we talk about envenomating teeth. Aglypha means no venom. All the snakes that are here today are aglypha. They cannot inject venom in you, no worries. And then we have opistoglypha, which means, opistos, anybody? No? Which means rare, behind. Meaning that the venom glyph, it's on the back part of their mouth. It's here, it's this one. And opistoglypha are usually referred to as the less dangerous of the venomous snakes. As a matter of fact, mambas are opistoglyphas. So you can get the chance of how these misconceptions are usually wrong. Another chance of the opistoglyph teeth is that they don't have a true venom canal. The teeth itself just has a groove through which the venom drips in the prey. And this is related to the type of venoms they can inject to the prey, but we're going to have a talk about venoms in reptiles. You're going to learn everything about this. Sorry for you. And then we have proteroglypha. Proteroglypha, such as like cobras, and the family of cobras is called elapids. Proteroglyphas, they have the teeth on the front part of the mouth, and they're always there. They never move. Usually this means that they have really tiny teeth, like in the order of some millimeters, not even a centimeter. Even the king cobra, which is like a snake that can get to 5 meters long, doesn't have teeth bigger than this. Which means that they have to rely on a really strong hold on their prey and on a really active venom. And then we have solenoglypha, which still have the teeth on the front part of their mouth, on the most rostral part of their mouth, but those teeth can collapse backwards when they don't need it. So they don't disturb their normal activities. Usually viperids are like this. They can collapse their teeth behind their mouth, and vipers are the snakes with the longest glyphs in the world, like the glyphs of death adder, Betis, if you, Vibora del Gabon or whatever. All of these animals, they have really long glyphs. Gaboon viper has glyphs this long. An adult one has like 3-4 centimeter long glyphs. And even though their venom is not really powerful, thanks to these really long glyphs, they can envenomate really deep inside the body, which means that the venom that they use, which is usually cytotoxic, attacking cells, can cause necrosis really deep in the tissues of the animal. And you can understand how this is really painful and really, really deadly. Then we have hemotoxic effects. The majority of vipers here in Spain, we have vipers here in Spain, they are hemotoxic venom. It means that at the same time it impedes the wounds to coagulate, but at the same time it creates blood clots circulating around the body, causing of course embolism and pathologies such as that. And then we have neurotoxic venoms, which act on the nervous system. So again, what's the difference between venomous and poisonous? Still no clue? Okay. We refer to a venomous snake to an animal that can actively inject its own venom inside of the prey, or whichever menaces it, such as cobras, such as vipers. Then we have poisonous animals, which are animals that usually, because of their particular diet, they intake venom of their prey, usually toads. As you might know, toads contain batracho toxins on their back, so they're like venomous to other predators. And they can reuse those toxins to become poisonous themselves. And this is a defense mechanism more than an attacking one. It's just useful when the predator is already chewing on you, which is really not useful. It's much more like a revenge kill, if you think about it. And then we have, and this is like all the snakes belonging to the genera Natrix. They're most likely toxic for the predators. So all of the culebra de agua that you can find here in Spain, if you eat them, you die. I wouldn't do that. And then there are snakes that are both venomous and poisonous, like this one. That's an Indonesia tiger snake, Rhabdophis subminiatus, or tigrinus, no, subminiatus. And they have an opistoglyph dentition, so they can use their own venom, but at the same time, living close to water bodies, they eat a lot of toads, frogs, etc. And they use up their toxins, which they secrete from this part of the hood, trying to imitate a cobra-like behavior to scare off their predators. I mean, look at the colors of this. If you're a predator, you don't want to eat that, especially if you're a bird, because birds can perceive colors much better than we do. So even for us, this is like yellow, white, black, red, green. Don't eat that. Please, don't touch me. You're gonna die, you're gonna suffer. Don't. Just don't. But still, if you try, you're gonna get literally food poisoning, which is not a nice condition if you live in the wild and staying agonizing on the ground, which could mean that another predator comes in and eats you. Husbandry. Again, husbandry, terrarium, what do they need? Heat devices. With snakes it's dangerous because they move a lot along the terrarium, so it means that if you use a lamp and you keep it inside the terrarium itself, there is a huge chance the snake is going to go there and try to wrap itself around it because it's a safe spot outside of high sight of the owners and of every other person. It's an elevated spot, but this will cause horrible burnings to the animal, even to the point of dying. They have a really high tolerance of pain, all reptiles in particular, and they can literally start frying up before feeling pain. So when you get home, you find them cooked around your lamp and they smell. It's not really nice. So what you do, you usually use heat mats and heating cables positioned outside but under the terrarium itself. So the snake will not stay in touch with the heat source itself, and at the same time it's going to be constantly regulated by thermostats, which control temperature and also times at when the heat mats on the heating source has to go on and off. Humidity, again, water balls. Some snakes are aquatic. In this sense, you have to create a thing which is a mixture of an aquarium and a terrarium. Incredible pieces of work. Like, I know that because of the lighting you cannot see on the back, but on the back there is a terrarium that was built in the zoo of Kalmar in Sweden. For a reticulated python that, as I said before, is the longest living species of the world. As you wish. I mean, this takes a room. This is a room of space just for one snake, because they have cannibalistic behaviors from time to time, so they don't want to keep more than one together. But yes, this is how, and the snake is here, by the way, and this is how you should, in scale, this is how you should probably take care of your animal. So when we talk about snakes, again, the same association that I mentioned before, they suggest that for a snake shorter than 2 meters, you should provide to them 40 square... You can keep it off if you want to, as you wish. You can, are you still recording? Okay, you can keep it off. You can use they can use a 40 square centimeters, a space of 40 square centimeters per centimeter of length of the snake itself, which means that a snake of 40 centimeters will need a terrarium of 1,600 square centimeters, which is not huge if you think about it, but still, it's quite of a something, especially because snakes in captivity, the normality for them is being obese. When you do an necropsy of a snake, and we will do a taller necropsia, you will see it, there is a chance that 70% are going to be obese. And then for snakes bigger than 3 meters, and this is where this comes into play, the minimum requirement for the snake behavior, for the snake normal behavior to develop is 90 square centimeters per centimeter of snakes. It means that if you have a snake of 3 meters, which is big, but it's still not huge for snake standards, you will need a 2.7 square meters terrarium, also known as the size of my bedroom. Is necessary for the welfare, having burrows and hides, of course, because snakes are not really active animals. They're really shy in general. So even diurnal ones, the one that moves during daylight, they try to stay hidden as much as they can, and then they come out to hunt. So when you see your snake going around the terrarium, it's either a new habitat, either there is a new smell, either they're possibly hungry. Substrate, all the rules stated before are still valid. Just beware the dust, because snakes, as you might have noticed, they crawl really close to the ground. It means that if the substrate is really dusty, all of the dust is going to be breathed in by the snakes, causing lung problems. Again, pneumonia. And careful with your terrarium, because snakes can escape like this. And they're like really experts of that. As for birds before, if you think it's not going to fit through a hole, it's going to fit, for sure. So just be careful with the snake not escaping. Hello. And again, you might hear that sometimes terrariums are too big. There's no such a thing as a too big of a terrarium. They're just poorly furnished ones. They probably tell you, oh, don't buy the definitive size terrarium for the snake. It's such a baby. It's not going to eat because it feels in great danger. Always been in an open space for the whole life. Of course it's going to feel like that if it has no hiding spot inside of it. I mean, if I put you inside a room like made of a glass this big, and I throw in random food at a time, you're going to be scared as well. You have no place where to hide. You have no place where to rest. Diet. Snakes are all carnivores. Some of them are specialized carnivores, some of them are just carnivores. For example, in the pictures there, that's the first square left, that's a king cobra, Ophiopagus anna. The name itself tells everything. Ophiopagus. It eats other snakes. It eats other prey items as well, but they like snakes a lot. Also because in their environment, the only snakes bigger than them is a reticulated python. King cobra is the longest venomous snake on Earth. It reaches 5 meters, a length of 5 meters, and that's a venomous snake. It doesn't constrict its prey. There's like this car that chases you with his mouth open to eat you, if you're a prey, of course. And that's the second one, second square on the right, that's Aplopeltura boa. It's a snake that eats exclusively snails. If you can see, the shape of its head is quite weird. That's because the cranium evolved in order to have a shape that when the jaw, as you might know, to snakes to eat, they have to detach the lower jaw. So when they eat the prey and the lower jaw goes back in its position, the pressure created by the big skull and lower jaw is going to crush the snail itself and evidently easier going down their digestive tract. That's lower left square, Ophoedris aestivus. It eats exclusively insects. It's a snake that eats just insects. Super hard and super expensive to keep in captivity. And that's Dasypeltis. That's a snake that eats exclusively and just eggs. Their sense of olfaction is so powerful that just by smelling the smell of an egg, they can understand if the egg is fertilized or not. And they'd rather have fertilized eggs, of course, because they contain much more nutrient. So, and what they do is using some modified vertebrae that are here. And when the egg is inside, with the peristaltic movement of its digestive tract, they just push the egg to the modified vertebrae and they break the egg so they can drink all of the yolk and the albumin of the egg and just spit out the shell itself because it's really hard to digest. In captivity, living, thawed, being defrosted, or leaving or pre-killed prey items. Depends a lot. And this is a matter of arguing, actually, and I really don't feel like arguing right now, but let's put it like this. Defrosted animals, they were killed in the shop, or they were killed by you and then frozen, meaning that the bacterial charge in their body, it's still present, but it's either dormant, either dead. It means that all the external parasites that a prey item can have are going to die, and if you kill them yourself, you breed them yourself, they're going to die in your freezer. So I don't know, I wouldn't like eating ticks, but it's out to you. And it also means that if you keep the animal, on the downside, if you keep the animal frozen for more than 3 months, and some studies say 6, so let's say 3 months just to play it safe, the quantity of vitamins inside in the body is going to decay, because vitamins are lipids. They cannot stand those cold temperatures for such a long time. In particular, snakes that eat fish, so natrix and other genera, they suffer of a hypothiaminosis, which a currency of vitamin B, which is caused by the fact that they feed them frozen fish, and vitamin B dies in the freezer in a matter of 5 days. I think it decays in the freezer in a matter of 5 days. So when you feed them to your animals, you also have to integrate your prey with some multivitaminics, even though usually this is not necessary, because considering that ophidians eat their prey whole, they intake not only what the prey is made of, but they also intake all the gut-loaded contents of the plates of the prey itself, meaning that they usually have everything they need to thrive. Actually, if you don't keep fish-eating snakes, it's really, really hard in captivity to see snakes with vitamin deficiency. It's actually quite hard. On the other side, if you use living prey items, you know that the snake is going to get much more stimulated. On the contrary, rats, mice, these are the most common prey items. They have a really, really dirty mouth, and they have a really strong mouth as well. So, especially not the ones that you keep as pets, of course, but the ones from shops, they all live together. So they tend to live in their own feces. It's not really hygienical. So when one of these animals bites your snakes, because it's a fight, it's a sort of fair fight between a predator and a prey. So when the prey fights off its predator, there's a chance you can kill the snake. I didn't want to put the gruesome pictures that you can easily find online of pythons kept hours with their living prey items inside their cage and found by the owners the day after with the mice or the rat eating the snake itself. This can happen with especially some like shy species of snakes. I mean, all snakes are shy, some much more than the others, and they're cute. Ophidians, market. Most common species, Python regius, king's python, ball python in English. Called ball python because, as you might see later on, when they're scared, their only mechanism of defense is making themselves up into a ball, and they just hide their head inside of their body, hoping that you will not damage them. That's how not aggressive these animals are. Pantherophis guttatus, serpiente del maíz, corn snake from the United States. Oh my God, again. Boa constrictor. We're gonna see one later on. It's the most common boa you can find in captivity. Lampropeltis, California king snakes, they go by the name of. There are so many of them. Usually in the wild, they also eat other snakes. In particular, Lampropeltis, which a harmless snake for us, has developed a defense mechanism that made his body not being affected by the toxin of rattlesnakes. So they can attack, kill and eat rattlesnakes with no consequence at all. And then we have a lot of snakes under the genera Elaphe. That's Elaphe climacophora, which is a snake from Japan. And then Morelia viridis. This animal, it's common in the market because it's really beautiful. It costs us usually a lot of money, but it's really, really hard to keep. Really hard to keep. It's normal to find these animals dead from night to the day after. And this is because they need really specific requirements for heat and humidity, and they usually are wild caught. So when you buy one wild caught one, there's a chance it's going to intake in your breeding facility or in your house, whatever, viruses that can be extremely deadly for these animals. In particular, the most deadly virus in snakes is the Reptarena virus, which causes a pathology which is called a disease which is called inclusion bodies disease, which means everything and nothing, because if you studied already for microbiology and parasitology, you might know that all the viruses, not all the viruses, but yes, all the viruses cause inclusion bodies inside cells. Some inside the cytoplasm, some inside the cytoplasm, some inside the nucleus. So when this virus was first isolated, they just says, oh, it causes a disease that makes the animal degenerate neurologically, and this disease creates inclusion body in the animal itself, which is really not descriptive, since that's the normal behavior of a virus. Even so, what you'll see usually, it's animals. Okay, maybe later. It's ataxic animals. Oh, okay, maybe now. And they have some really clear neurological signs, such as opisthotonus, which means that there is a contraction of the muscles of the backbone, basically. So the animal bends his head backwards. That's also referred to as stargazing. Now the animal seems fine, but as soon as they stimulate it, you'll see it's not able to put itself back into the normal position. This is a neurological vestibular problem. And this is quite a good one, because as long as it doesn't get upside down, it's okay. But there are some of them that cannot keep their head straight. So you'll just see, this is opisthotonus, this is stargazing. The muscles of this part of the neck are blocked. The animal cannot put his head down, even wanting to. See, that's referred to as wobble. Some animals wobble all the time. And sadly enough, there is no way to cure the disease known to humans right now. So usually animals found like this, they are euthanized, or they're just kept as long as the neurological symptoms, alterations, don't grow worse and worse and worse. Okay. Talking about obesity, I don't know if you know, there is a really cool girl on Facebook that has a Facebook page called Helen Cairo with a K. And she lives in the US, and she makes these amazing didactic posters about herpetologies, about the necropsy in particular. And she was the one finding out that that the 70% of snakes that are brought in the necropsy field, once the necropsy is done, they are not only overweight but also obese. You shouldn't be seeing a fat deposit so high up in the head of the snake. So as for we have in dogs and cats obesity and body weight charts, now we also have for snakes. I honestly invite you to go on the website Anatomica, written with a K, Anatomica Science, because she sells these posters, she keeps updates about her scientific work. It's insane. She's really good. I'm talking about hypovitaminosis that I forgot to mention before. Snakes can suffer of a form of snake scurvy. Escorbudo in Spanish, I think. Do you know what is scurvy caused by? What causes scurvy? The pirate syndrome. Every pirate's had it because? Exactly. They didn't have vitamin C. In fact, until they didn't discover that eating oranges while on really long boat trips was actually helpful for their health, they would just die on the crossing between here and the New World. Chelonians. We go with turtles. Animals belonging to the order Testudines. The order contains, as said before, since it's really old, contains both extant, which means living, and extant, which means non-living species. Some of them being much older than the most common dinosaurs. They adapted to live in every sort of environment except air, obviously. And these anatomical adaptations are so complicated that they got to avoid getting affected by some diseases that can kill humans as well. Like, the biggest sea turtle is Dermochelis coriacea. What's the name in Spanish? Some of you posted an article on the group the other day. I don't remember. Whatever. Look it on the web. Look it up. This turtle, it's super big, and it swims in the coldest waters of the world. It swims up to Antarctica, and it swims up and down from Arctica to Antarctica. And what it does, it has a really black skin, because in the short times when it stays on the surface of the water, it has to capture as much heat as the turtle can, because imagine how hot can it be on the poles. It's really freezing. So they try to stay exposed to the sunlight for as much time as they can without being predated or being menaced by other animals. And as you might know, this in a normal animal could cause melanoma. But they evolved a special type of melanin that covers all the upper part of their body, by which, even though they stay exposed to the sunlight for the whole part of the day, they don't get melanoma whatsoever. They're incredible animals. Husbandry. This gets really hard, because even though you might not think of it, there even are some tortoises which are arboreal. Means they live not on trees itself, but they can climb up on trees. In particular, Malacocersus tornieri, the tortoise on the left, also referred to as pancake tortoise because of two features. It's really, really flat. It's like, the height is like this, and the shell is sort of soft, like a pancake. This happens because they have to climb on really high rocks, and they like to live between the grits of these rocks themselves. It's incredible. And then also, of course, we have water tortoises, and even though seawater ones are not legal to keep in captivity, thanks God, freshwater ones are. And they can space from like being this big to being like an alligator tortoise, which is, what, 100 kilos, I think? Or something like that, 80 kilos, 100 kilos. It's a really big animal, and sometimes it can be even dangerous. So I'm not gonna bother you with numbers this time. I'm just gonna tell you what you want for aquatic tortoises is to have them to have twice the length of the carapace of water. So if the carapace measures 20 centimeters, you want to give them at least 40 centimeters of water, except the turtles such as Celus fimbriatus, mata is the common name, that can extend their neck twice the body, no, as much as 1.5 times the length of the carapace itself. In that case, you want to give them as much water as for them to stay on the bottom of the aquaterrarium and still be able to elongate their neck up to the surface and breathe from it. And then you have land tortoises. And for those animals, the best solutions in general would be to keep them outside as much as you can when the climate allows it. Now, here it's really common having Hermann tortoises, Testudo hermanni. In fact, we have one here walking in the back of the class. And the optimal, now that we live in Spain, France, Italy, Greece, wherever, would be keeping outside for the whole year, even during winter. Diet. Herbivorous tortoises follow the same rules that we stated for saurians, remembering that some of them should also, naturally in nature should also have a protein intake even though they're herbivorous. Then we have carnivorous tortoises, which are, most of them are freshwater. Okay, actually the term tortoise and turtle that I'm using without discrimination, it can scientifically be used without any discrimination, even though in English tortoise is land and turtle is water. Forgive me, I'm not going to pay attention to that. They are carnivorous, the majority of water ones. And they eat, depending on their size, insects, mice, rats, fish. And then you have omnivorous ones that can eat everything that the other two can eat combined. And usually when we're talking about an omnivorous reptile, it means that when it's really young, it eats much more proteins, and then by the time it becomes bigger and bigger and close to the adulthood, they become almost exclusively vegetarians. This is all the same with lizards. Market. The tortoises are not really common anymore among amateurs because they're really expensive. They can get really big, such as the Geochelone sulcata, And they are not easy to take care of, even though people believe they are. They're probably the most endangered reptiles on the market. In fact, I don't believe that there's any turtle nor tortoise being sold without any document attached to it anymore. Sexing. We're going to see about this better later on. Just know that sexual dimorphism varies a lot depending on the species. In particular, in land tortoises, what we try to look for is a sort of depression in the plastron, which is plastron in Spanish, which is the most ventral part of the carapace of the tortoise itself. If it has this depression, it means that we have a male. If it doesn't, it means that we have a female. We also look for characteristics such as the length of the tail. The male has a much longer tail because it needs the tail to attach to the female during the copulation itself. And then there are secondary sexual characters that can be present for the majority in freshwater tortoises such as Emis, Trachemis, Pseudemis, all of those ones. Generally speaking, the tortoise with the longest claws is a male. Because, as you might see in the Facebook video that went viral in the last days, the courtship in freshwater tortoises consists on the male doing this movement on the face of the female. And that's the female gets to understand that the male wants to reproduce with her. Again, best technique, DNA analysis. Common pathologies. Non-infection due to bad husbandry, for sure. Then we have respiratory diseases, which are really common because of herbavirus and mycoplasma. And then we have the septicemic cutaneous ulcerative disease, which is a disease caused usually by two different bacteria. We have bacteria from genus Serratia that cause the first lesions, and then in the lesions proliferate the Schictobacter freundi, which causes the degeneration of the turtle shell and skin up to this point. This is still a pretty severe situation, but it's not of the worst cases you can see. Like the shell can get pierced by these bacteria. It's pretty much what happens for those of you who have done microbiology with foot rot disease in pigs. There are two different bacteria acting at different times. And they, like when one of them colonizes the wound and causes the wound, then it dies off and leaves free-ranging sites for the second bacteria to go there and thrive. This causes a generalized septicemia, especially multifocal, hepatic, and necrosis in other organs as well. Hemolysis, lympholysis, lophodages or claws, cutaneous vasodilation, and hemorrhage. It's a really, really severe disease that should be taken as a differential every time you're brought in with a tortoise that has degeneration of the shell or of the skin in general, together with hypovitaminosis A, especially in water tortoises, since they're fed those really shitty dried up prawns that contains no nutrients whatsoever. They just contain a little bit of chitin, which gives them some energy to thrive for like 1 year or so, and then they die. Amphibians. This is going to be really fast because sadly amphibians are not taken care of in the normal veterinary clinic. This happens because amphibians are a really, really huge family, and they can vary, and being a huge family, it contains animals that can vary in size from 7 millimeters, such as that frog, which is the Pedophina manuensis, that is here put on a dime. A dime is a 10-cent coin, 10-cent dollar coin. It can be 7.7 millimeters long. It's like this. To the Andrias davidianus, which is the longest amphibian living. It's the Japanese giant salamander that can get as long as me, 1.80 meters. Imagine a salamander walking here, being 1.80 meters and leaving slime on the ground because they're really humid and stuff. And particularity of amphibians is that they're waterbound, always, especially when there are larvae, because amphibians do go through metamorphosis, much as like insects do. Especially when there are larvae, the great majority of amphibian larvae they live in water or in close contact with them. And even then when they get to adulthood, they cannot live away from water because their skin always need to be moistened, because as you might know, skin it's a mean to exchange liquid, for amphibians it is, a mean to exchange liquid from outside to inside, but also it's a respiratory organ for most of them. So the smaller the animal, the more chances there are that they have no lungs and they just breathe through the skin, like this one. It has no lungs whatsoever. This is why when we get to have an amphibian, we never ever handle it, because there are some techniques you can do with them, like you can use gloves. So the sweat from your hands or the lipids on your hand are not gonna obstruct the breathing pores of the skin of the frog's skin, and also because we have a different pH than them. So touching them could cause them really, really serious harm. So when we have to, we use gloves or we moisten. We don't use soap. We just quickly moisten our hands with water. But shite. Yeah, well, whatever. In general, we don't touch them at all. In particular, their terrariums has to be replicating the natural environment at 100% level. And this means in particular automatic misting systems. You can buy them, or if you're really good with computers, you can actually create them by yourself. It's super cool. You just have a small corner of the rainforest in your bedroom and it activates lights normally and it rains and you can hear the frogs singing. And when you have frogs in captivity, to have them reproduce is creating a rain chamber. We have to simulate the rain season of their natural environment. And I mean, having frogs singing in your bedroom can be really nice, but not when they're reproducing, trust me. It's really, really annoying. They're gonna keep you away at night and they're never gonna stop for 2-3 weeks. Can lead to really serious problems in the owner, I mean. And amphibians diet, strict carnivores. When you create a terrarium that contains all of the insects that are gonna clean the soil by itself, you probably have everything they need, because they're also gonna eat, the frogs are gonna eat those insects and they're gonna defecate, and those same insects are gonna thrive on their feces. In particular in frogs, the less you have to work on your terrarium when it's like working by its own, it's going on by its own, the better. That's the general rule. Vitamin grey integration, fundamental with frogs in particular. Market. They're usually cheap, but very demanding. We have, from left, Ceratophrys, which I usually refer to Pac-Man frogs because of their color and because of their tendency to eat everything that stands in front of them, much as like Pac-Man does. Then we have Ambystoma mexicanum, that you might know as an axolotl, and it's a really interesting animal because what you usually buy and keep in captivity is the larval stage of the animal. That's not the adult axolotl. What happens is that in the lake where they live, or at least they used to, they're extinct in the wild, or pretty much getting there, in Mexico, what happens is that all the prey items, for some reasons, they lack of sodium. Therefore, their thyroid gland has stopped producing T3 and T4 autonomously, so they just evolve differently. They're just gonna stay in the larval stage until the end of their days and reproduce from that stage. In fact, in captivity, if you give them T3 and T4, they're still gonna metamorphosize to adult stage, but they're gonna live a couple of months, then they're gonna die, because that's not how they're doing normally in the wild, or at least how they were doing in the wild. Really interesting is that they have a great regeneration. You can cut off one of the limbs and it's gonna grow back in 1-2 months or so, perfectly normal as before. That's why they're studying them for regenerative therapy in humans as well. Then you have Chinops orientalis, which is the fire-bellied newt. Is a newt. It's like a salamander that lives in the water. I cannot explain simpler than this. And then we have Pyxicephalus aspersus, which is the bullfrog. Called that because of the huge dimensions and because of the noise that it makes in reproductive seasons. It really sounds like a mooing of a cow. They can be really big. They can get to 3 kilos or something. A frog, so it's like this. And they are usually extremely aggressive, even mutilating each other. That's why they should be housed alone. And they have really big incisive teeth on the most frontal part of their mouth that can get this big in the adult exemplar. So when you get a bite from those animals, it is not really, really nice. And then we have Xenophus laevis, which is the flat frog, I believe the name is. That it's an animal that was kept because it's really easy to take care of, actually. It just needs an aquarium. But this means that when people get bored of it, they just release it in the wild. In fact, in Italy, it's now becoming an invasive species. Dendrobates, you might know them as dart frogs, because in the wild they eat insects that contain a lot of alkaloids. They resynthesize those alkaloids into a toxin that they use to cover their body with in order not to be appealing to predators. Again, look at the colors. You don't want to lick that. That's not the frog you want to lick to get high. If you do that, you get dead, actually. So Native Americans, what they do is they used to brush those frogs on their arrows and use the arrows to kill their enemies. Humans. Dendrobates, really common frog, really low level. It's usually advised for beginners. They sing, they have a really peculiar sing, and they're really, really loud, even though they're like this big. And then my favorite one, Agalicnis calidrias, the red-eyed palm frog. That's why I don't like common names, come on. It's so ridiculous. And they are among the most common arboreal frogs in the market, nonetheless the harder to keep, because they need a really big rain chamber in order for them to be stimulated into reproducing, and then it's hard to keep the small larvae to go up to adulthood, but they are amazing. In a terrarium, they're really beautiful to see. Actually, owning amphibians is much more like owning a fish than owning any other earth animal itself. Sexing, again, it's just really hard. Some of them are primary characteristics, some of them are secondary characteristics, some of them are no characteristic whatsoever, and sometimes you find them reproducing. Great. Depending on the species though, females are usually bigger than males. So during mating season of frogs, it's not rare to see a big frog and a small one on top. What happens is that they don't have a copulation as the ones of terrestrial animals. They have it much more like fishes, for example. Fish do, for example. The female is stimulated by the male, and then either she lays eggs and the male puts his sperm on the eggs themselves to fertilize them, either the male releases its spermotheca, which is like a bubble containing sperm cells, basically, and the female uses it, takes that spermotheca and puts her inside the reproductive system, and then she lays eggs. Anyway, eggs are always laid in water. So if you go in water ponds in April, May, you will see like super long strings of black dots. Those are frog eggs, and depending on the shape in which they are deposited, you can sometimes tell the species of the animal itself. Again, the only difference in big salamanders and toads usually is that males have nuptial pads, which are basically, I really wouldn't know how to say. They're like structures on their feet that are rubbed against the female, and the female likes it so much she decides to lay her eggs at that point. Common pathologies. Non-infectious, again, surprisingly due to bad husbandry. Hypovitaminous A, traumas, respiratory distress, severe dehydration. Infectious, fungal diseases. There's going to be Lander, who is not here today, may his soul rest in peace, who is going to talk to us about Batrachochytrium dendrobatitis, which is a mushroom that has been discovered in the last years and is now killing off all of the frogs in the wild. And this is really sad because, well, for the frogs themselves, but also because being delicate animals, amphibians in general, are indicators of how well our environment is doing. Meaning that if there are no amphibians, you should start getting worried about pollution in your area. Ranavirus, really common as well. And parasites, usually they don't have external parasites, they just have internal protozoans. Clinic, again, nothing much to do but suggesting how to correct the husbandry to the owners. And this is it, finally.